On April 15, 2019, an inferno tore through the roof of Notre Dame Cathedral. Within hours, flames consumed the 850-year-old timber framework, sending massive plumes of smoke over the Paris skyline. The heat weakened the 300-foot spire structure until it finally buckled, collapsing inward and crashing through the roof into the nave below. Watching the collapse, onlookers around the world assumed the worst. The general consensus was that the centuries-old Gothic masterpiece was completely lost to the ashes. But as daylight broke and firefighters poured the last streams of water onto the smoldering stone, the true picture emerged. The iconic twin towers, the massive exterior walls, and the delicate rose windows were all still standing. The survival of the main structure was the result of an intentional, interlocking defense system built into the stone itself. The cathedral endured because the 12th century masons who built it implemented a highly specific system of structural engineering. They designed a framework that, in the event of a catastrophic fire, would effectively sacrifice its upper half to save the whole. To understand how this system works, we have to go back to the year 1163. Bishop Maurice de Sully wanted to construct a monument that would dominate the Parisian skyline, pushing interior vaults to a record-breaking 35 meters. This ambition created a severe physics problem. Builders wanted to flood the interior with natural light, meaning the walls had to be hollowed out and filled with fragile stained glass. Yet those same walls had to somehow support thousands of tons of stone roofing. This diagram shows the core issue. Gravity pulls the massive weight of the roof straight down, but that downward force is redirected by the interior arches, creating a dangerous outward lateral thrust that threatens to push the walls apart. The builder's solution was the flying buttress. These 12-meter exterior stone braces act like giant hands pushing back against the lateral thrust, holding the walls securely in place. By transferring the heavy structural load outside, these external supports allowed the masons to strip the interior walls down to a skeletal thinness. Moving inside to the ceiling of the nave, we find the second major structural innovation, the 6-part rib vault. This architectural diagram highlights how these specific vaults operate. The interlacing arches gather the immense weight of the ceiling and channel it safely down into specific reinforced pillar points, creating a solid 30-centimeter thick stone umbrella directly over the congregation. Looking past the surface of those vaults into the pitch-black attic space reveals the final, massive layer of structural reinforcement. Here, carpenters erected what became known as the forest. It was a sprawling, densely packed structural framework built from the freshly cut timber of roughly 1,200 perfectly straight oak trees. This massive timber roof wasn't just a cover from the rain. The sheer, crushing weight of all that oak pushed straight down onto the tops of the walls, locking the stonework tightly into place. The wood and the stone relied entirely on each other to stand. Fast forward back to the evening of April 15, 2019. When the fire ignited inside the forest, it threatened to unravel this delicate symbiosis. As the oak framework burned away, the immense downward pressure locking the walls together vanished. Without that weight, the lateral thrust could have blown the walls outward. However, the exterior flying buttresses absorbed the shifting load, keeping the stone skeleton completely upright. Meanwhile, the heavy, flaming timber beams and the molten lead from the roof had nowhere to go but straight down. This cross-section shows exactly what saved the interior. The burning wooden roof timbers collapsed downward, but slammed directly into the 30-centimeter thick stone rib vaults. Aside from isolated areas that fractured under the spire, the stone umbrella held firm, shielding the hollow nave below. The stabilizing force of the flying buttresses, the sacrificial heavy wood of the roof, and the impenetrable shield of the stone vaults combined to absorb the energy of the collapse. By solving the physics problems of the 12th century, the master masons accidentally designed a flawless 800-year-old fireproofing system. Today, the center of Paris is dominated by an enormous restoration site. A dense cage of metal scaffolding wraps entirely around the stabilized ruins, supporting the creation of a brand new roof framework. The restoration teams faced a brutal deadline: repair and reconstruct an 8.5-century-old monument in just 5 years to meet a target reopening in late 2024. To meet that deadline, engineers made a highly unusual choice. Instead of replacing the destroyed roof with a modern steel or concrete framework, they committed to rebuilding it using the exact architectural methods of the 12th century. That meant sourcing 1,000 flawless oak trees from French forests and utilizing medieval techniques. Modern carpenters laid down their power tools, picking up traditional hand axes to manually square off the massive logs, carefully matching the grain and physical strength of the original timber. As the massive web of scaffolding is finally disassembled, the results of this painstaking labor are laid bare. A pristine, lead-clad spire once again pierces the sky, set against stonework that has been cleaned of centuries of soot. The perfectly symmetrical western facade glows exactly as it did hundreds of years ago, honoring the precise vision of the ancient master masons who first sketched its lines in the dirt. This arrangement of limestone and oak serves as a physical reflection of a human condition. A careless spark can erase centuries of history in a single evening. Yet, the painstaking restoration proves that our collective drive to rebuild, to preserve, and to honor human craftsmanship is stronger than the forces of decay. That resilience is what keeps our greatest monuments standing. Thanks for watching. If you want to see more deep dives into the engineering of the past and present, make sure to subscribe and turn on notifications so you don't miss the next video.